Example 14 wants us to prove that sine of x times sine of y is equal to 1/2 times the quantity cosine of x minus y minus cosine of x plus y. So I am going to start off with the right-hand side. And we need to use the sum and difference identities for cosine. So let's remind ourselves, cosine of alpha plus beta is cosine of alpha cosine of beta minus sine of alpha sine of beta. So cosine, cosine, sine, sine. And then we'll just swap the minus and the plus if we were subtracting. So this is going to be 1/2 cosine of x cosine of y plus sine of x times sine of y minus cosine of x cosine of y minus sine of x sine of y. Okay, so now let's go ahead and distribute that negative sign in here. Okay, that works out really nicely because notice we have cosine of x cosine of y here and then minus cosine of x cosine of y. So those are like terms and those will cancel out. And then here we have the same exact things. So this will equal 1/2. Those will cancel and we get 2 times sine of x times sine of y. And the 2 and the 1/2 will divide. And that's just going to equal sine of x times sine of y, which is equal to the right-hand side, and we are done with that example. All right, well, here are the list of product to sum formulas, and we just derived this formula here, and you can take a look at the other ones. Example 15 says, express cosine of 3x times sine of 7x as a sum of trigonometric functions. So first things first, I'm going to take this and I'm going to rearrange the order, which we can do since multiplication is commutative, which just says something like 7 times 3 is the same thing as 3 times 7. So in multiplication, we can rearrange the order. So I will write that as sine of 7x times cosine of 3x. And now that becomes useful because I can utilize this third identity here where 7x is our x value and then 3x is our y value. So if I plug that into the formula, I'm going to get 1/2 times sine of our first value, which is 7x, or our first angle, plus our second angle, which is 3x, plus sine of our first angle, which is 7x, minus our second angle, which is 3x. And now if I simplify the stuff inside of both parentheses, we get 1/2 times the quantity sine of 10x plus sine of 4x. Now, I just want to make a note, like algebraically, just make sure that you're not thinking that this equals 1/2 sine of 14x. Like we definitely cannot do that. If you wanted to simplify this further, we could distribute the 1/2 in. So we got 1/2 sine of 10x plus 1/2 sine of 4x. And we can't really do anything further with that, so let's just leave our answer as that. That concludes example 15. Here are a list of sum to product formulas that will become useful, especially in the next example. So example 16 says, prove that sine of 3x minus sine of x all over cosine of 3x plus cosine of x is equal to tangent of x. And I am definitely going to be starting with the left-hand side. And if you look at the list above, we have sine of something minus sine of something. And so we're going to end up utilizing this formula for the numerator, and then for the denominator, we are going to end up utilizing this formula. And so what we can do is we can think about this as our x value, and then this as our y value, and then same thing in both of these scenarios there. So in the numerator, I can rewrite this as 2 times cosine of the first angle, which is 3x, plus the second angle, which is x, over 2, times sine of the first angle, which is 3x minus the second angle over 2, like that. And that completes the numerator. And then for the denominator, I can rewrite this as 2 times cosine of the first angle plus the second angle over 2 times cosine of the first angle minus the second angle over 2. Okay, so let's see what we can do from here. This 2 and this 2 will divide out, and then notice that this thing and this thing are the exact same cosine values. And so what that leaves us with is sine of 3x. Actually, let's simplify the inside of the parentheses. So 3x minus x is 2x. So we'll have 2x over 2. And divided by cosine of 2x over 2 as well. And so the way that we got to this point was through division. We divided out those terms there. And then we simplify the inside of the parentheses further. So 2x divided by x is just x. And then same thing with the denominator. 2x divided by 2 is x. And so we got to this stage by also using division again, and then we know from the reciprocal identities that that is equal to tangent of x. And that is equal to the right-hand side, so we are done with this example.